All right, so today is Java 1 Lesson 2, and today we're going to be talking about something called data types. So, a review from last week. So last week we reviewed the following print statement, and this one's your generic one, so system.out.println, hello world in quotes. So we also reviewed this statement, and you can see here that we don't have quotes here, and we add it together. And so notice that the second printment doesn't have quotation marks, and that's because hello world with the quotation marks is a string, while 5 plus 9 over here is not. Disregard like the quotation marks around here. And I'll be in the following slides, I'll explain like what exactly is a string and what 5 plus 9 would count as. Right, so strings. Strings always have to be contained in quotation marks or else Java will count it as incorrect syntax. Strings can be a number of different things, but the main discerning feature is the quotation marks around the content. It is also possible to have empty quotes and still be considered a string. So strings is something we call data types, and there will be more examples of data types in the following few slides. And there's also an example slide with different types of things that are counted as strings. So you'll see more about what exactly is counted as strings. But a way you can think of it is that strings are, they're like strings of characters in a way. So again, I'll be showing more about what it is. Nice, so string examples. Over here, you can see a column of strings that we have, and you can see that we have the 5 plus 4 here, but this time we have quotes around it, so this is counted as a string. We have hello world, in quotes again, 9, in quotes again, and empty quotes here. So these are all counted as strings, and that's because they all have quotes. You can notice that these all have quotes here, even though there's numbers in between them. So strings are not necessarily all characters like these, like letters. They can also just be numbers and symbols. It doesn't have to all be strings, all be letters. The only thing that matters is that they have quotation marks around it. That's what makes it different from other things. And over here, you can just see some not strings. You can see a 9 without quotation marks, plus sign, hello, without the quotation marks. These would all not be strings. And you can notice that these don't have quotes while these have quotes. Concatenation. Okay, it's a long word, but trust me, it's not that difficult. So concatenation is just when you add numbers to strings or strings to strings using the plus operator. So for example, you have system.out.println. In quotation marks, you have 3 plus 4 equals, and then plus a 7. So normally in regular math, you would say, this is not correct. It's not supposed to be like that, right? But in this case, it works because it's Java. So notice here, what's inside here, it's counted as a string, right? So we're adding a string to a number 7 here. And in that case, the output would be 3 plus 4 equals 7. And that would work as normal. So caution with concatenation, and that kind of rhymes, sorry. Not really, but something you can remember. So notice here that when we have a print statement with 3 plus 4 equals the string plus 3 plus 4, normally if you look at this, you would think, oh, it's gonna output 7, right? 3 plus 4 equals 7. No, it does not, because it outputs 3 plus 4 equals 34. And you might be like, why? It's because Java operates using the regular order of operations, PEMDAS. And if you don't know what that is, it's parentheses, exponents, multiplication, division, addition, subtraction. So, which is why this is so. Because so the string is kind of counted as a number in a way. So it still falls under the PEMDAS rule, which means that it's first going to add this 3 plus 4 equals to 3, and we would have 3 plus 4 equals 3. And then we would add the 4 after it. So then it becomes 3 plus 4 equals 34. So it doesn't add together. It adds this string first before like it prints it out. So the way you would fix that would be is if you added a 3 parentheses around 3 plus 4. So again, if we're going by PEMDAS, since parentheses are first, that means that we solve everything with the parentheses first. So this would first calculate to 7, and then it would add to 3 plus 4 equals, and that would actually output 3 plus 4 equals. Again, this would be the correct way to use concatenation in this case. So just be careful of what you're adding to the strings, since it might be different. Data types. So general definition, data types are types of data, as the name suggests. Strings are a type of data, but there are also others, since you can't all have just strings, right? So data types will be useful in coming lessons. Make sure to use the correct data types when writing programs. Yeah, so just in general, these few lessons are more background lessons, just so that you're going to be comfortable with the coming lessons when you're learning them. So background information, nothing too important yet, but it will be important later on. So we have a table here, and these are the common data types. So first one we have here, the first one's name is integer. And you probably have heard this in your math classes, depending on where you are. Integers are defined as, sorry, probably shouldn't get ahead of myself. But anyways, written in Java is int, so int, lowercase I. And this contains regular whole number integers. There's a certain range of numbers that count as an int. There is a certain range, but I'm not going to go over it here. If you want to, you can search it up and you'll find it. But I'm not going to go over it. Just know that there is a certain range that counts as an int. And we'll go over some over here that will have a larger range than int. But yeah, you can see here that it's basically the same as regular math, regular whole number integers, so negative and positive. So it goes both ways. The only thing that's different is that it has a range. Next one, long. And written in Java, it's long with the lowercase I, sorry, L. So this contains a larger range of regular whole numbers than int. So for example, if you were gonna write a program that had you had to use really large numbers, then you would use long instead of int, because if you use int for that case, then Java is gonna come up with an error and you're not gonna be able to continue. Doubles, next one. In Java, it'd be double with the lowercase d. And these are decimal numbers, and these also have a range. Yeah, again, I'm not going to put the actual ranges here, but you can search it up if you want. Next one, characters. And in Java, they'd be something called char with a lowercase c. This is one character, so that can be a letter, a number, or other symbol. Chars are enclosed in single quotes, so you can see here that it's right here. On your keyboard, it'd be the one right under the double quotes. So that's how you find it. Make note that it's only one character. It can't be two characters like AB. That would not count as a character. But if you put A there, it would work. If you put 9 there, it would work. If you put a plus sign, it would work. Yeah, so just make sure you make clear what characters are and what strings are. Oh, also, just again, kind of like string, characters are defined by these single quotes. So anything that has single quotes around it, and that would be counted as a character. Anything that has double quotes around it would be counted as a string. Next one, Boolean. So you might have heard of this one as well, and in Java it'd be Boolean with a lowercase b. This is basically just true or false. Double examples, just to clarify a bit more. So doubles, you can see here that we have a 4.0, and that counts as a double because it has the 0.0 after it. So it doesn't matter if this could simplify to an integer. As long as it has a 0.0 after it, it counts as a double in Java. And we have the typical 5.9 and negative 35.1. So negatives and positives, it both counts. Not doubles. You can see here that we don't have 0.0 here, so it's not counting as a double. Negative 6, not a double. 0, also not a double. Make note here that if you added a 0.0 after this 0 here, then it would count as a double. So 0 is still possible to be counted as a double. The main discerning feature here again is just the 0.0 after it, or decimal point. Character examples. So again, notice the similarity here. They all have single quotes, and we have exclamation mark, the letter A, 4, L, and the \n. So in this case, \n counts as one character. So that's why you're able to do that. Other data types. So these are more not commonly used than other ones. So there's only a few. I'm just going to go over them, but you're not going to use them much since they're not really something that's really efficient with programming. So first one is float. Written in Java, it'd be float with a lowercase f. So these are imprecise doubles and takes up less storage. So imprecise doubles meaning that it might be a little bit, there might be round off errors, which means that they don't give you the correct answer. So like if you had long decimal numbers after the decimal point, then it might round some of it off just because it's imprecise. But generally though, it takes up less storage. So if you were to use float, it would probably be because you're trying to use less storage. Storage meaning computer storage, meaning that it takes less computer space and could possibly make your Java program faster to execute. Next one, short. And in Java, it'd be short with a lowercase f, s. And this contains a smaller range of integers than int. So again, generally, you're probably not going to use short, mainly because you already have int, and that contains a lot, like a medium range of integers. So you're mainly not going to use that much. Similar one to short, byte, and written in Java, it'd be byte with the lowercase b. This contains a smaller range of integers than short. So again, this is even less likely to be used, really, since you already have int and short and long. So there's kind of no point to using byte unless, again, you're trying to save storage or you're working with really small numbers. Primitive data types. So primitive data types include int, double, char, short, byte, long, boolean, and float. So notice that strings are not counted as primitive data types. Strings are something we call a user-created object, and you'll get into that more later in other Java courses. But just know that strings are not what we count as primitive data types. Primitive data types are data types that are built into Java. So that means that when you start using Java, it's already there for you. You don't have to program it into it. which again is a concept that you'll learn later probably. So yeah, they just come with the programs. Later on, there will be times when you can program your own data types, but those won't be counted as primitive data types. So just know that these are examples of primitive data types. All right, I think that's it for the lesson. So kind of a long lesson, but it's important background information. In a second, we'll be doing class problems. All right, so these are the class problems for today. And again, these are kind of simple problems right now, but we're going to be getting into harder problems later. So it's important to have the basics down so that you're going to be prepared for those problems. But otherwise, yeah, these are the problems. Just make sure you do them and you understand how to do them. You understand what the answers are going to be. Yeah, otherwise, that would be it for this lesson.